Now let us understand some of the key aspects related to DDL as well as indexing. So when it comes to DDL, we can perform DDL operations such as creating and dropping collections, which we have already seen earlier. We can also add indexes and drop indexes. Once again, we will reiterate that we can drop a collection by saying db.collection name. So as of now, we have this collection by name order details under the test database. We can actually say dot and hit tab. You can see there is a drop function. If you use drop, the collection will be dropped for us. If you want to create a collection, that is available on top of db, where we can actually say create collection, and we can create an empty collection without any attributes associated with that collection. On top of creating and dropping the collections, another common DDL statement, DDL function, is to create or drop index. So we can first get the list of indexes by saying db.orderDetails.getIndexes. It will give us the list of indexes. As of now, there is only one index on _id, which is nothing but the system generated field for each and every document which is inserted into this order details. Same is the case with the collections in retail database. You can actually say db.orders.getIndexes as well as orderItems.getIndexes. To create an index, we can say db.orderItems create index. If you are not sure about the syntax of a given function, you can just hit enter after typing till the end of the function name. You can see that the create index takes keys and several options. So in this case, we will pass the key. The key is nothing but order item, order ID. The options can be whether we want to sort the data in ascending order, descending order, etc. So it is supposed to be of type object. We have to specify like this. Now the index is created. We can actually say db.orderItems get indexes. We have two indexes now. One is on _id. Second one is on order item already. As order item already is indexed. Now if we switch to use test and say db.orderDetails.count, the execution will be much faster. Now it is almost inserting 1700 documents to 2000 documents every second compared to 10 to 15 documents every second. So that's the power of index. It need not do full table scan for each and every lookup into order items now. It can actually perform index scan where the data is pre-sorted based on this order item already. However, once we start creating indexes on a MongoDB collection, the writes on this collection will become slower. Even though the lookup into this collection become faster, whenever we try to insert documents into this order items collection, they will be a bit slower because it has to update index as well while inserting the document into the collection order items. That being said, adding indexes will slow down write operations but speeds up the read operation. _id is automatically indexed. We can create second indexes using create index over the collection. If you look at the create index statement which is executed, you can see as per syntax we have specified db.the collection name, which is nothing but order items, and then create index. And as part of the create index, we have passed this JSON object which contains the attribute on which data is supposed to be indexed and 1. Which means when this index is created, the data will be sorted in ascending order by order item already. If you say -1, it will be sorted in descending order by order item already within that index. So that's the relevance of this one. If you don't want a index, you can also drop that index by using drop index function, and it will take care of dropping the index from our collection. That being said, by now the data might have been loaded into this order details successfully. We can validate by saying db.orderDetails.count. It should contain 68,883 records. You can see here. You can review the data by saying find and then pretty. If you want to validate for a given order ID, such as order ID 2, you can see that we have all the order information such as ID, date, customer ID, status, along with the order item information in the form of a list. With respect to 3, as there are no records in order items, we only have the order details such as order ID, order date, order customer ID, order status. So this is how you should be able to use the JavaScript programs to reconcile the data. And whenever we have to perform lookups, if we actually index those fields on which we want to perform lookup, then the lookups will be much faster, even though the writes will become a bit slower on the collection where the index is created.